Okay, let's get started. So today we're going to cover the first topic in the syllabus. We'll start off by doing a lot of definitions. You're probably familiar with most of them anyway. So I'm just going to go over what functions are and some ways we can represent functions and some uses of them. Section 1.1, functions and their representations. So basically functions help us to model situations where we want to talk about relationships between objects, right? And there are special relationships between objects. Before we get into some applications, let's actually talk about the mathematical definition of a function. Do you guys remember what that is? What's a function? What is a function? How would you describe it? Don't be shy. Come on, talk to me. What's a function? Can you guys give me examples of functions?
X plus 1 is a function, right?
X plus 1. Do we agree x plus 1 is a function? Is there anything missing? Yeah?
A second variable. Actually, that's y equals.
Like y equals, okay. Like y equals x plus 1. Okay. Yeah, by itself, if I just say x plus 1, what am I saying? What is that? What would we call that? We just call it an expression, right? A mathematical expression. And when I give you an equation, this is one way to describe a function. It doesn't have to be a function. Not all equations are functions. So there's a little bit more to it than that. For example, x squared plus y squared equals 1 does not describe a function. Can you tell me why? What are the differences? What makes something a function? What kind of relationships are functions? This one is a function, this one is not. Yeah?
Does it have to be a linear relationship?
Do you have to be a linear relationship? Do we only have linear functions?
Yeah.
Okay. What else? What other kinds of functions are there? Give me other examples. Yeah?
Like y equals x squared plus 1.
Y equals x squared plus 1 is also a function. That is a function of x. Yeah?
Any alphabet for TC x, any alphabet for TC x, TC equals to any function related to x.
Oh, now you're talking about notation. So we can say like y equals f of x where this represents a function of x. Yes. But so in general we don't know what a function is? Okay, so let's actually start with that. So a function is a rule that assigns to each element in one set, which we call the domain, exactly one element in another set. Called a codomain. The elements in the codomain that are assigned are said to belong to the range of a function. Right? So a function is just a rule that assigns elements in one group to elements in the other group. Okay. So you can think of, and it can be mathematical. So I could do, for example, let's go run with this example, y equals x plus 1. Just doing a pictorial representation. Okay. Which means if I'm given a number over here, say 1 or 2 or 3, a function that I can call y equals f of x, which has the definition of x plus 1, and we'll talk more about what that means. What it does is it makes assignments. If this is my domain, and this is my codomain, then the function is going to take this number 1 and assign it to what number? Y equals x plus 1. It's going to bring it to the number 2. So the number 1 and 2 are connected by a relationship, this relationship, which we call a function. 2 would connect to 3, 3 would connect to 4, and so on, right? So that is a function. It's a relationship between two groups of things, a very special relationship, such that each person in this group is assigned only one person in the other group. Okay? Exactly one. Right? The reason why this guy is not a function is because you can have more than one assignments for each individual. Right? If I plug in, say, x equals a half here, there are actually two y values that can solve this equation. And that's a problem. Functions, you only can have one answer. Right? So that's basically what a function is. It's just a way of grouping things together, assignments. And you can think of it as mathematically, and you can think of it in other ways as well. So it doesn't only have to be mathematical equations. Okay. Let's do another example. Let's say y equals f of x. But here I say f of x equals something like x squared plus 1. I'm gonna draw a picture of this again. Let's throw in some more numbers here. -3, -1, 0, 1, 2, and that's a bunch of other numbers in here. So what would -3 go to?
10.
Well, how do you know it's 10?
Plugging in -3 to, yeah.
Right.
so
This is going to be the rule, and we'll probably discuss this a little more as well. So the rule says square the number that I'm plugging in, add 1. So I square 3, I get 9, I add 1, so that maps me to 10. If I square 1 and add 1, that will bring me to 2. If I square 0 and add 1, that will bring me to 1. If I square 1 and add 1, that will bring me to 2. Connects to this guy. And if I square 2 and add 1, that will bring me to 5. That's another example of a function. Now let's say I'm thinking of the real numbers here. I'm thinking of all the real numbers here. Can you tell me any number that will never be assigned in this rule? A number that I can never actually connect to someone. Yeah.
0?
0 will never be assigned, right? There's no number I can plug in here that will give me 0 there. And there are a bunch of ways we can see this, and we'll talk more about all those ways as well. But there's no number I can plug in for x that will give me 0. Okay? No real number anyway. Okay? And so what we, in that is where this part of the definition comes in. It talks about the range. I would say that 0 is not in the range of this function because it's never assigned to anyone. Okay? So these numbers here, there's a subcategory in the codomain which we call the range. Right? And those are just guys that can be assigned. So that's the theoretical definition of a function and one way we can represent it. Any questions? So, is it starting to look familiar? Because you guys probably didn't know what I was talking about before. So, now let's talk about Variables are basically symbols that represent something. We use variables to represent domain elements. And range elements. So the domain elements, the guys that are in the first group, we often call those inputs. And then the range elements, we often call it the output. So a function can be every math textbook has a picture like this, where you have some function, or this is a rule, that it takes some input value coming from the domain, and it assigns it an output value that goes into the range. Some typical variables that are used. X represents arbitrary input value. Y would represent the corresponding output value. You can also recall that we can name functions like this. You can also name functions. So an example here, let's talk about some notation. Say y equals f of x. Right? So when I write something like that down, my y is the output. It is the range element. It's representing a general range element. The f, that's the name of the function. We can often name functions by using letters. And x represents input element. So basically, this notation says I have a function that I'm naming f. It takes input values x. It does some rule to them to output a unique value y. So that's one thing you want to remember in a function. Each input has one corresponding output. So let me ask a question. Let's say my relationship is being a parent, right? P-A-R-E-N-T. Is that a function? Would you describe that relationship as a function? Can any parent have exactly one child? No, it's possible to have more than one child. So that relationship would not be a function. What if I said being a child, is that a function? That relationship. Right? Because you can say, in terms of biologically, right? Like a biological father, right? You can only have one, really, you know? So that's an example of function. So it's very theoretical at this point, but you can apply it to real life situations. And we will be doing that a lot in this class, but you really have to understand the theory. Because when you talk about real life situations, things can get kind of fuzzy. You know, there are words and we attach all these meanings to them and stigmas to them, and sometimes you lose sight of things. What the math does, it helps you be objective. So when you sort of condense things down to an objective level, you can properly reason and properly think about things. And so we want to describe a special kind of relationship, and it's called a function, and it's a very common kind of relationship to see in the real world. Let's talk about some ways to represent functions. We're talking about functions and their representations. One way to represent functions is what we call a mapping diagram. Which is basically like the picture that I just showed. So an example of functions would be something like a diagram where you can see everyone going to one thing. You can write some examples here and find out their corresponding guides there. You can also have something like this, where you have several people going to one thing. These are both functions, right? Because each person here has one line emanating from them to connect them to someone else in the group. Something that is not a function. So if you're describing a relationship and it looks something like this, right? We have this one thing in the domain mapping to two things over there, it's not a function anymore, right? So this is like a father having two children. It can't be a function. It's not the kind of relationship we care about. So that would not be a function. It's also not a function if we connect things, if not everything in the domain is assigned. So let's say I have connections for the first two, but I don't assign anything to the third person, I'm also not a function, right? A function, the whole point of a function is to make an assignment, to make some sort of connection. If we're not making connections with everyone in the domain, it's not considered a function. Okay? So it's certain type of relationships that talk about connecting elements in two groups in a specific way. That's what we call a function, right? And the reason why a circle is not a function, when I wrote down the circle, x squared plus y squared equals 1, is because I can have one x value giving me two y values. Okay? And that's a problem. So that's one way to represent a function, is using mapping diagram. Another way to represent a function. We can use formulas. These are rules written down using mathematical in the sense that, you know, back in algebra class. So for example, I can describe a function f of x equals x plus 1. Right? That will give me one output for every x value I plug in. We can represent functions with tables, values. Sometimes called numerical representations. So that's, say I have the function f of x equals x plus 1. I could also have given you that information in the table, where I said, okay, here are the x values, and you can write down their corresponding y values in the table. Okay, so I can have 0, and that will go to 1. And I can have 1, and that will go to 2. And I can have -1, and that will go to 0. And I can have 2, and that will go to 3. So So I can tell you in a picture, as I've done before with a mapping diagram, that's when we first started the example over here. I could give you as a formula where the rule, I use mathematical languages to tell you what to do to the input. Add 1, square it, divide by 2, do something to it. Or I can give you in a table. Another way to represent a function is using what we call graphs. And these are mathematical pictures. So I can look again at the function f of x equals x plus 1. And you usually put the input on the horizontal axis and the output on the vertical axis. And it's really just coding this information that we had before, but now you're doing it on a picture. So I know that 0 would go to 1, if I have 1, that would go to 2, if I have 2, that would go to 3, if I have 3, that would go to 4, etc. And it creates this picture when I plug in all the numbers. And all these different representations, they have different uses. Depending on what I'm after, I can use a different representation. These are just some of the very common representations that you'll come across in this class. By far the most common representations we'll see in this class are formulas and graphs. If you're doing statistics, or you see tables a lot. But even in statistics, you eventually turn tables into bar graphs and all sorts of other pictures as well. Because pictures really help you get quick information where you can make very generalized statements very quickly. So again, it's all about the goal of the analysis you want to achieve. Any questions so far? I'm really just dumping a lot of information on you. Well, you have things like verbal, and these are pretty much word problems. This means the rule is described in words. To each element, add 1. Right? You can describe something verbally, right? And a lot of times you're reading word problems. This is what you're doing. You're actually translating from the verbal representation of a function to a graph or a formula or something like that. Another common representation is to use coordinates. A set of points. So if I wanted to represent f of x equals x plus 1, I could actually write that down as saying f is equal to, and I write coordinates where I put corresponding numbers. It's another representation. Going to work through an example which is going to sort of see where you guys are, and then we'll move on from there. But first, I should give a little mention. That's just a heads up. Translate all the implications. These two ways, using formulas and graphs, mathematically speaking, they're very easy to manipulate and work with. So let's actually, I'm going to give you a word problem, which is going to be, well, it's not really a representation of a function, it's a representation of a problem. And we're going to actually use functions to help us solve this problem. We'll see how well we can read and apply something. It's going to be a word problem, so prepare to write for it. So here's the situation. Jhevon's hot dogs. So the teaching thing isn't enough. I have to sell hot dogs on the weekend to make ends meet. Okay? And where you would get this information from typically would be actually statistics. Someone would go out and measure things. So I just know after selling hot dogs for a long time, if I charge $3 per hot dog, I would roughly make 50 sales in a day. If I charge $2 for hot dogs, I would roughly make 80 sales in a day. So that's the situation. Okay? Suppose let's try to start this over here. Keep things moving in that direction. A. Suppose we define a function a to p to represent the number of hot dogs sold at price P. First of all, interpret that expression. So I have this situation and I define this function, and we'll see why this function is useful later. But for now, let's just suppose we define this function. Okay? So I call my function, I name the function h for hot dogs, and I'm taking p to be my input. Right? P is price. So if you see the expression h of 3, how do you interpret that expression? Yeah?
Well, since we know that at $3 you sell 50, we can interpret it to be 50. The function would equal 50.
Oh, yeah, okay. So we'll get to that later, but what you did was you evaluated the function, which is not what I wanted. It's different. So you're actually telling me what the value of this expression is. I want you to interpret it in words. In words. So if I say h of 3, what would this represent to you in words?
It's at $3, how many hot dogs are you selling?
The number of hot dogs sold when or if price is 3. Right, so usually when I say interpret, that means to actually explain something in words. If you're giving me a value, like you're telling me, oh, this equals that number, that's called evaluating a function. I'll talk about that more in a bit. But that would be how you would interpret that expression. Right? I just wanted to make sure you guys understand how this notation is going to work. So B. Can you tell me what are the domain and range of H if Jhevon will only sell for $2 or $3? How would you talk about the domain of this function? What would the domain of H equal? What would the range of H equal? Can you give me as a list of elements? What is the domain of H? Yeah?
The domain of H is 2 and 3.
2 and 3. What would the range be?
Yeah.
50 and 80. So I'm kind of going from some sort of situation I'm describing in words, and I'm actually showing you how you think of things in mathematical terms, right? So let's go over this. Why is the domain 2 and 3? What is the domain doing? Yeah?
It's the input.
Right, the domain is the set of input values. Now I define my function and I put the p in parentheses, which means p is representing my input, which means my input in this interpretation would be price. And therefore the list of domain elements would be the possible prices. Okay? H is my function. H is describing the output. That is the number of hot dogs sold. Therefore, if I talk about the range of this function, it would be the possible numbers of hot dogs I can sell. So here's a question. What is the, and this one's going to be a little bit challenging probably. What is the best price to sell hot dogs? Assuming Jhevon is willing to vary price. And we got this. So we'll talk about what this means. It's basically the nice name for this would be called revenue, but when we get to economic function, we'll talk about this. So what is the best price to sell? So first you'd have to interpret what would best mean in this interpretation. What would my goal be in selling the hot dogs? Yeah? To profit more. So my best price would be, how would you interpret that? It's the price I would sell in order to
make the most money.
make the most money. Okay, so here I have that situation. I have this hot dog stand. I know I did research data, right? So I did research and I have this data. You know, if I sell hot dogs for $2, I can sell 80 hot dogs. If I sell it for $3, I can sell 50 hot dogs. Now I want to know the best price. Let's make it actually easier than that, because this is situations can be very complicated. And say we have cause to believe that they have a linear relationship. It doesn't have to be the case, but let's say I'm just making it a little bit easier. Okay, reason with me now. How do you think we'd go about solving this problem? Yeah?
You can multiply the input, which is the price, by the output, which is how many transactions happen. So
What's how much money we make? Yeah, sure. Okay, so let's start there. So basically the idea is we want to make the most money, right?
Yes.
Okay. And now we can go with your idea, the money we make. Right? In very simple terms, it's going to be the price that we're selling the hot dogs for times the number of hot dogs sold. By the way, what you just did was you invented another function. Okay? This is a rule that's going to tell me how much money I make. Okay, so let's start there. What can we do now? Yeah?
I guess you plug in the numbers.
We need to plug in the numbers. What numbers? Yeah.
2 and 80.
Sure, that will be how much money I sell for 2. But listen to the question. I didn't ask you how much money do I make by selling it for $2. That's not what I asked. I actually know that information already. I want to find the best price, which it's possible that it's 2. It's possible that it's 3. It's also possible to be something else. We don't know what that price is. So what do you do when you don't know what something is and you want to find it? Yeah. Use variables. That's what algebra is all about, right? Finding the unknown. Okay? So the price I'm looking for is the best price. I don't know what it is, so I'm just going to use a variable to represent it. What variable do we want to use to represent price? P. That's what we started out the question. So let's call that P. What can I say to represent the number of variables sold, hot dogs sold? How would I figure that out based on the information over there? Ideas. So to recap, I know 2 pieces of information. I know how much I can sell at $2, how much I can sell at $3. I know they have a linear relationship. What do you guys think? Remember the 2 common ways that we want to represent functions, because I said they're the most useful in doing math. What were the 2 ways?
Formulas and graphs.
Formulas and graphs, right? So here I want to use a formula because that'll be easy to answer the question, but I kind of am stuck. So I probably can switch to the other interpretation, right? So how would I use a graph here? What would be on the horizontal? Price. Because the input goes on the horizontal. And on the vertical, that would be H, the number of hot dogs. I know 2 pieces of information. If the price is 2, I will sell 80. I also know if the price is 3, I will sell 50. Okay, so that's what I started out with. But then I have reason to believe they have a linear relationship. What do you think that means?
The
Yeah.
slope is the same.
In terms of a graph, what would it mean? If I say something has a linear relationship.
It's a line.
Hmm?
It's a line.
It's a straight line. These points are connected by a straight line. Okay. Now this is a picture of what? The number of hot dogs I'm selling, which is exactly what I want to put here. So now that means the formula I need to put here is the same as the formula for that graph. How would we find the formula of a line if I know 2 points on the line? Taking it back to algebra, but way back. Yep.
You find the slope first.
Find the slope. How would we find the slope?
Formula.
Yeah, what's the formula?
Y
Right, take the difference in the outputs, divide by the difference in the inputs, make sure you do it in the same order. So in this case, that would be what? 80 minus 50 divided by 3 minus 2. Right? So that would be what?
Yeah, would it be 2 minus 2?
2 minus 3, yeah.
Yes. We started with 80.
I'm starting with this coordinate. So the 80 goes with 2, and then that. Yes. And so what would that be?
30.
Okay, what else? How else would I get to this? So one step in finding the equatorial line is to find the slope. What else do I do? Yeah?
We then plug in one of the points with the slope in the formula. Or the,
Okay, which formula are you thinking?
y equals mx plus b.
Okay, so there are 2 ways you can do this. So let's do one. Is to use the y equals mx plus b formula. Of course, here my y is h and my x is p, but it doesn't matter. They're just only. So what is the idea here? What would I plug in? Continue. How would I finish this?
You plug in 80 for y, negative 30 for m, and 2 for x.
And then I can solve for b that way, right? So what would my b be in this case?
140. 140, I think.
That would be 30 times 2 is 60, so it's 80 plus 60. Yeah, so it's 140. All right, so one way I could describe this guy is to say, instead of y, I'm going to write down the letters I use. H is equal to minus 30 p plus 140. So that's one of the formulas. Another way you could have done this, by the way, there's another formula that's very commonly used, which if I'm plugging in one point, personally I prefer this, but you don't have to do it, so I just want to show it. Y minus y1 equals n x minus x1. That sounds familiar? Yeah, and you can sort of do the same thing. You plug in the points here, plug in the slope there, and so this is y minus y1 is going to be 80 minus 30 x minus. And so you'd end up with y is equal to minus 30 x minus 2 plus 80. Expand the parentheses, you have minus 30 x is 60 plus 80, and then you get back. Okay, so there are 2 formulas you can use. But at the end of the day, now we end up with a formula, and we just put that here. So that's how much money we make. I'm going to call it R for revenue. Very suggestive. I know we didn't really define that yet, but that's okay, now what can we say? So that's how much money we make. How do I make the most money? Do you guys know what kind of function that is? Yeah?
So you want to make the prices.
It's a what?
Linear function.
Is this a linear function?
Oh, it's p times. It's
R is going to be minus 30p squared plus 140p. What kind of function is that? Hmm? What? What? I can't hear you. Yeah. Quadratic. Okay. Do we know how it looks? What it looks like? What would the picture look like? Just do the shape of your finger. Let me see if you know it generally. Huh? Like this? It looks like this?
That's one, right?
That is a parabola. Would this parabola look like that?
Silhouette.
Yeah.
It's the other way, right? Why? Because there's a negative in front of it. So I know the picture looks like this. Right? And if that's the picture that talks about how much money I make, which point do I care about? This point. Biggest point. What do you call that? That's called a vertex. Right? We want vertex. How do you find the vertex of a problem?
Where slope equals 0.
It is where slope equals 0, but we don't really know how to deal with that at this point. That will take some calculus to do it in that way. You guys remember from algebra, formula for finding vertex?
Yeah.
K and H.
No.
Huh?
You put it back to the equation that I minus b squared.
For vertex. I'll just tell you the formulas. You'll probably remember it after I say it. P, the input value, will always have the formula minus b over 2a. Is that familiar?
Yes.
Is that something?
Yes.
Minus b over 2a is how you find the input for the vertex of a quadratic or a parabola. That's not true for every kind of function, only for parabolas. Right? A is the coefficient of the square term, b is the coefficient of the linear term, and c is the constant. So in this case, my p would be minus b, minus 140, over 2 times minus 30. Zeros would cancel. That gives me what? That gives me 14 over 6, or what? What is 7 over 3 roughly?
$2.33.
Huh?
$2.33.
So it turns out in this situation, right? So let's say I have a hot dog stand. I know if I sell for $2, I sell 80. If I sell for $3, I sell 50. I know there's a linear relationship between the price and the number of sales. Then it turns out the best price to sell for is $2.33. And I use functions to come to that conclusion, right? No trial and error, you can solve for it once you have all the information. So, we'll end there. Hopefully you guys can sort of see how something like this can be useful. Hopefully you also see how much algebra you need to remember. You guys need to brush up on your algebra. Come on. Take this weekend and actually go over that stuff. Know about equations of lines, parabolas. You have to know about those circles, solving equations in general, factoring, look over all that stuff. And we'll pick up on Friday.
So this is the